Good day, learners. Welcome to our geography discussion. Our discussion basically today, we are going to focus on map work section for both paper 1 and paper 2. And specifically, we're going to focus on the GIS section, part of map work. I understand we all know that our papers comprise of map work question, which is question number 3, if you are talking of the June examinations and the November examinations. They do, and also for grade 12, the preliminary examinations, they have a map work question number 3, and a part of that map work question, there is a section for GIS, which is 8 marks. Right, so in our today's discussion, we want to focus mainly on GIS concepts. We want to look at the basic concepts that fall under the GIS section. And by GIS, we are referring to the Geographical Information System. Right. So to start with in our discussion, we want to start with the Geographical Information System as a geographical concept. What is it about? We want to look at what is Geographical Information System. Right. According to the simple definition that we have here, it is saying GIS is a collection of computer hardware. That's number 1. We have computer hardware. And on top of hardware, we have software. And we have data. And we have people. And lastly, processes. So we are saying it's a collection of those computer components of hardware, software, data, and we also have people and processes that are designed. What is the purpose? What are they designed for? Though that collection, what is it for? It's designed to capture, to store, to update, manipulate, analyze, and display spatially referenced data. So you can see it's a very broad definition. It's a broad definition that comprises with a number of aspects that need to be further elaborated on to make them simple and to make them more understandable. So we have talked about a collection of hardware, software, data, people, and processes. Those are what we refer to as the components of GIS. We refer to all these as the components of GIS. They are the ones that make up the GIS. And what is it used for? We are now looking for the purpose for GIS in geography. What do we use geographical information system for in geography as an area of specialization? We capture information or data, we store it, we update it, we manipulate, we analyze and display. All the data which is spatially referenced is also another geographical aspect or geographical concept that we need to look at into detail. Spatially referenced data. Right. So as you can see, this is a composite definition that one might not memorize the way it is. So what I encourage you as learners in defining concepts is to define in the most simple way of your own understanding. As long as you address the basics of the definition, then the definition will be correct. You cannot memorize all definitions the way they are presented in the textbooks, the way you saw them on the internet, or the way you got them from all other various sources. But however, you need to capture the idea. You need to get the basic idea because it's a concept. You need to have the idea and present the idea in your own understanding. Right. So basically, when we are trying to sum up this definition, we are mainly referring to the application of computer systems in the study of geography. We are applying the computer system or the world of computers into the study of geography. That is basically the idea behind the GIS or the Geographical Information System. We are applying modern computer technology towards the study of geography. We capture geographical information. We have to store it for future use. We have to update it whenever there are some changes which are happening. We have to manipulate it to suit the different needs of people. We have to analyze it, make informed judgment from the information that we have. And we have to display it for purposes of study So we are saying we are incorporating the computer technology system into the study of geography. And the computer system is made up of different aspects. It's made up of different components. Like the hardware, we're looking at the physical equipment that we use in this computer system. The software, the data, the people who are there to capture information, to process it, to store it, people who are there to use it at the end. And the process is the different processes that happen throughout the geographical processes, throughout the geographical process of using GIS. We talk of processes like remote sensing is part of the processes that befall the GIS as a system. Right, so basically that's the idea behind GIS as part of the study of geography. Right, so we want to move on and look at the components of GIS. We are looking at the different aspects that make up GIS. What is it made up of? Right, we've talked of hardware. When we're talking of hardware here, we're looking at the physical components of the computer system. Those ones which are physical. For example, we can give an example of a monitor. That is a physical component. Or we can talk of the keyboard. Or you can talk of a printer. Those are hardware components of GIS, the physical aspects that we use in the computer system. Then the software, we're looking at those different forms of software which are used to come out with the geographical information system in use. We have different softwares which are used in geography. The different softwares are like, you can talk of ArcGeography. It's a software which is used in geography to actually come out with a way of presenting geographical information. Or we can also talk of other softwares like Microsoft Word. You can talk of PowerPoint. All those forms of softwares which are used actually to store the information or to present the information when we're displaying it. And then we are going to look at the data. When we're looking at data, we're looking at this is form of information which is not yet processed. So it's unprocessed information that has been captured that need to be put into the system and to be processed now into more useful information. We collect data from the field, we collect from surveys, we collect using different methods or from other maps. We collect such information, it's unprocessed. Then we have to process it to make it more useful. So we have the data as part of the components. Then people, or we can call them personnel. These are the different categories of people that are involved in the GIS process. For example, those who capture data, the data capturers. There are people in the GIS system, the people who capture the data from the different sources. They capture the data and put it into storage into the GIS system. We can talk of people who are responsible for the manipulation of information. We can talk of different groups of people in the GIS process until we get to the end users. Those people who want now to find information about geography, those are the end users. After the information is captured, it goes through quite a number of people. Some of the people have to update the information. Some of them have to process the information to make it more useful. Some have to present the information in different formats so that it's more user-friendly. And then at the end user is also part of the people who are the beneficiaries of the GIS process. You can now go to the GIS databases and be able to access information that you want. Then we also have processes that do happen. Processes like manipulation of data. We can talk of processes like standardization. Processes like sharing of data. Those are the different processes that happen throughout the GIS process. So basically, these are the components of GIS. The basics of GIS is made up of hardware, according to our definition. It has also had software, it has data, it has people and or the personnel. Then it also has the processes. Right. That's basically the components of GIS as part of our study in geography. Right. With the components, that is basically the components of GIS as we have discussed in those five components. We tend to move on and look at what follows from the components of GIS. So basically, you can see we are simplifying on the major components which we enlisted in the definition of the GIS. We are now trying to elaborate on what each and every component is about, what it does in the system of GIS, and what it is basically as a component of GIS. So here we have some summary of the components of GIS. It has the data, which is indicated there by those different layers of information. These different layers, they present the data that we can put in a GIS system. Then we have the hardware components. I think you can see those ones are physical, like the monitor that you can see there. Maybe also have some printers. We might also have all those physical components of the GIS. Then we have software, the software in the form of those applications that we use in storing information and displaying it. Then we have the people who are responsible for managing the GIS process and also storing information, manipulating it until it gets to capturing information, storing it until we get to the final users of GIS. Then we have applications, which are also the processes that happen within the GIS process. So basically, that's a summary of GIS and its components as summarized by that illustration that we have just gone through. Right, let's move on. We move on to the functional elements of GIS. Remember, they were also part of the definition. The definition gave us the components and also the functions of GIS. The functions, we are saying, what do we use the GIS for in geography? What do we use geographical information system for? Why is it necessary? What's its rationale in geography? What do we use it for? Right, so we are saying in this dimension, the functional elements of GIS. Right, number one is capture. Right, we're talking of capturing of information. We're talking of capturing of geographical information. Right, that's the first one, of capturing information. When we're talking of capturing, we're looking at a system whereby we get to access different forms of data from different sources. So when you're capturing data here, there are so many ways of capturing data. We can use primary sources to get our data. For example, if we do surveys, we can go around and try to find information as geographers about a particular event, or we can do field visits to collect the information. Right. And also we can rely on secondary sources so that we can capture the information. Secondary sources, we are referring to information that is already available. The information is already there. Maybe we are looking at newspaper articles. The newspapers have established such information and it's in print. We can also access it and capture it in the GIS system. So we can talk of newspaper articles, or we can refer back to maybe census information. We know the government does the population census, which is also equally important in the study of demography in geography. We can refer to that census presentations and also be able to capture the information for use in geography. So basically, that's how we can capture the information, right? That is capturing. Then we have storage of information, right? The information is stored in the GIS. And we are going to look at how the information is stored. We store information in different formats. So we are storing the information so that we can access it for future use. And also we store the information for comparison and update purposes. Right, you have stored the information for this current year. Maybe it's information about rainfall statistics. We have captured it and stored it in the system. And then maybe next year we capture again the same information about the rainfall pattern. And then it means after 5 years, we can now be able to draw trends in the changes in rainfall patterns. We can make comparisons from season to season, given that we would have captured the information. So such information, we store it in the system and we'll be able to access it in future. We'll be able to make references in future of the past, and we'll also be able to make comparisons of the current information against information from the past. So, and also we'll be able to make forecasts through storing the information. Through reading analysis, through statistical analysis, we can be able now to forecast the future predictions of the same of the trend in the same geographical phenomenon, because we'll be having quite a series of information from the past to the present, so we can actually be in a position to predict the future. Right, then we also talked of the GIS being used for updating information. We can use it for update of information. Right, updates. Right, information stored in the GIS system might need to be updated. We might need to change it to suit the present. The present situation. Maybe it's population statistics. Our population statistics, maybe for the previous census, we are having it stored in the system, maybe saying the total population is standing at 116 million, according to the past year census. And then in the current year census, we tend to find that the population has changed. Maybe it has gone up to 210 million. We cannot keep relying on this information here because it's now out of date. It is now out of date and no longer applicable, which means we need to go to the system and update the system to the current nature of population. It has now changed from 116, now it's at 210. Then we need to update the information to make sure that it's suiting the current trend, is suiting the current geographical trend, which is prevalent in the real world situation. Right, that is with updating of information. Then we can also look at manipulation. Information can be manipulated. When we're talking of manipulation of information, we are basically saying the information can be changed. In fact, to change to suit the specific needs of the user. Maybe you're saying the information is presented in the form of maybe a table format. We are having maybe information presented in a table format. Maybe it's about population of different provinces. Maybe it's Gauteng. Then it has males, it has females, it has children, then it has total. Right, like that. Then we have our statistics there. It's province, then it's Gauteng. Maybe males, we are having maybe 900,000. And females, maybe 1 million. And children, maybe 600,000. Then we get our total. This is information in a table format. We can also manipulate this information to change it to another way of presentation. We can present this information using maybe a bar graph. The same information that we have on the table here, we can present it on the bar graph. We are manipulating or we are changing the information. Maybe someone can best is more comfortable reading the information or reading the population trends from a bar graph. Then they might not be comfortable with using a table. They might be more comfortable using a bar graph. Then we can manipulate this information. We can change it from this table format to a bar graph format to make it more user-friendly. That is with manipulation. So we use GIS to manipulate the information to change it to some more desirable and user-friendly method of presentation. And then we also talk of other aspects of manipulation, analysis of spatially referenced data. We can analyze the information which is spatially referenced. For example, we can look at the population trends, the population change in trends of the change in the trends of population, which is spatially referenced. We are saying in Gauteng, how is the population changing? By analyzing trends over time. We can analyze the trends over time. Is it increasing? Is it decreasing? Is the number of men increasing or decreasing? Is the number of women increasing or decreasing over the given time frame? That is analysis. We can make analysis of that information which is spatially referenced. Right. Then we move on to types of data in GIS. Right. We have what we call spatial data and what we call attribute data. Right. I usually encourage learners to be specific here. When I'm talking of types of data and ways of storing data, those two are not the same. You must never interchange the two, or you can never interchange those two. When I'm talking of types of data and ways through which data is stored in a GIS system, is different. So when we're talking of types of data, we have two types of data, which is spatial and attribute. Right. Let me go to my whiteboard. Right. When we're talking of the types of data, in GIS, we have one, spatial data, and two, we have attribute. What is spatial data? This is data that talks about the location of a feature, the shape of a feature. Right. We are looking at the location of a feature. Location, when we're talking of location in geography, we are looking at the coordinate system. We are trying to analyze the location of a feature on the geographical space through the use of coordinates. Or in which shape does it fall? What kind of a shape is that object or that feature? That is spatial data, according to the two types of data that we have. It describes the location and the shape of geographical features. That is spatial data. Basically, location and shape. So any form of data which gives us the location of a feature, of a geographical feature, and which gives us its shape, it's spatial data. Then we move on to attribute. Attribute now, to make it simple, you can say it's descriptive. It's descriptive data. Descriptive in what sense? It gives us the features or the characteristic of the feature. It tries to elaborate on the feature. It gives us the features of that particular geographical space or that particular geographical thing that we're discussing about. So when we're talking of attribute data, right, let me cite an example of one feature. Right. Let's say we have a school on a map. Right. We have a school on a map, and maybe the school is X, Y, Z high school. XYZ high school, when we are looking at it in terms of spatial data, we are looking at where is it located in terms of coordinate system. Maybe you can say its attribute, its spatial data maybe it's located at maybe 33 degrees, 12 minutes and 32 seconds to the south. And maybe it's located at again 18 degrees. This is longitude, maybe 45 minutes and maybe 52 seconds to the east. This is spatial data about XYZ high school. And also if you can describe its shape, maybe it's occupying a rectangular space. That's the shape of the school perimeters. That's its spatial data. We are looking at the shape of the school and we are looking at its location. That is spatial data. Then we go on to attributes of the same school. We are still referring to XYZ high school. Right. Attribute data for this school, we can start by its name. What is the name of the school? It's XYZ high school. This is descriptive data. What kind of a school is it? Is it a primary or a high school? It's a high school. We are describing it. How many learners are there? Maybe it is accommodating 1,200 learners. What nature of ownership is the school? Is it a public? Is it an SGB school? Is it a private school? Maybe it's a public school. Trends about the pass rate. What was the 2024 or any other year's pass rate? It had 100% pass rate in metric. You can see the difference here. Here we are describing the school. We are giving more details about the school. We are talking about the features of the school. This is now attribute data. It's no longer location or it's no longer the shape, but now we are giving the details about the school. So this is attribute. And this is spatial. Those are the two types of data that we have in GIS. Right, then we move on to the ways through which data is stored in a GIS system. Methods of storing data. Right, our data in the GIS system, now we're looking at data storage in GIS. Right. Data storage and presentation. Right, number one, data is presented as vector, is stored or presented as vector data, and two, as raster data. Those two. Do not confuse types of data and methods of storing or of presenting data in GIS. Right. Data is stored in the form of vector data. What you should remember is whenever you're talking of vector data, remember how information is presented on a topographic map, so that you don't forget. Remember a topographic map. The way through which features are portrayed on the topographic map is the raster format. And if you want not to forget the raster data, remember an orthophoto map. Right, we're going to look at that in detail. So we are saying in using vector format, the data is in the form of a tree. Some features are presented. Right, we're going to look at the tree and also going to look at the way of presentation of data here. Features are presented using the format of points. And features are also presented as lines. And features are presented as polygons or the area features. Right, that is with vector data. Then we go on to raster data. For example, the orthophoto map. All right, our information here is presented in pixels or in grids, the features. That is basically the summary of vector and raster data. Raster data is typically a topographic map. How features are portrayed on the topographic map is typical of raster of vector data. A topographic map, if, for example, we are presenting a road on a topographic map, the road is just marked by a line. Or if it's a river, it's just marked by a line. This can be a road, this can be a river, or a power line. These are just lines. And we also have some other features which we call the points, features which are not big enough to be regarded as an area feature or a polygon feature. For example, a spot height, just like a dot, like this. Then maybe it's 1, 2, 4, 1.6. This is just a point representing a spot height. Or maybe a building, a small building just like that. You cannot say it's an area feature. It's just like that. Then it's presented like that. So this will be our point features on the topographic map. This will be our line features. Then we go on to polygon features or area features. These ones are the ones which are big enough to have a perimeter around, which encloses. For example, like this. If this is a recreational ground, it's an area feature. It has completely enclosed boundaries. Or maybe you can have something like this. And then in green, this is a cultivated land. It's an example of an area or a polygon feature. Or maybe you have a play field. Play field. This is also an area feature. So on a topographic map, those features which are big enough and have got boundaries which are enclosed, they are the ones that we refer to as area features or polygon features. Right, area or polygon features, those are the ones. Right, so we are saying that is how a vector data presents or stores information in GIS. It uses points, lines, and polygons or area features. Then raster data, we use pixels and grids. Pixels and grids, by referring to pixels, using, this is now raster data. Pixels, we are looking at the images here. Images which are taken using a camera, they are presented in pixels. They are giving us the real image of the particular feature. For example, the same road that is presented by a line on a topographic map. If you check it on the orthophoto map, it actually gives you the actual image of the road. You can actually see the markings of the road. And also you can actually see the actual width of the road. Instead of just using a line, it's the same road which is presented in a line using vector format, but using raster now is presented in pixels, which is an image. We are now seeing the actual image which has been taken by a camera of the same road. Instead of us just drawing a line, now we have the real road being shown as the way it is on the actual ground. Right. And also we use grids. Grid presentation. We are saying we have got small grids and features take those grids, take the nature of those grids to actually portray how they look like. For example, if this is road, this is the road that you are portraying here. The road might be taking this whole block here of the grids along this. If it's a straight line road, it will occupy these grids. And maybe let's say there's an intersection here, another road coming from this direction. The grids will also occupy this. So it will have the same nature of the road, but is portrayed as an image here, or here is portrayed in the form of grids. Right? Maybe we can go on. We can go and look at how the data is presented. Right, vector data refers to presentation of an area using points, lines, and polygons. This is vector. Like you can see examples of points that we have here. We have those three dots. They are indicating a presentation of information using the points. Then lines, you can see the lines that we have here. And then lastly, we have polygons or area features, where we can give examples of those area features like the dams, like you can talk of recreational grounds, you can talk of cultivated lands, you can talk of whatever has got a definite shape or has got a shape which is enclosed falls under a polygon or area features. Then vector data refers to presentation of an area using points, lines, polygons. The example that we have here, this is an extract from a topographic map. Like you can see here, unfortunately, the map is not very clear, but this is an extract of a topographic map. Like what we've been talking about, if you want to figure out an area feature, you can actually see that there's cultivated land here, which is in the form of an area feature. Like if we are to trace this cultivated area, you can see that it's starting from somewhere there. It has a boundary, which is enclosed. It comes here, it goes there. Right. We go on with that. This whole area here is enclosed and it's cultivated land, which is in the form of a polygon. So it's a polygon feature presented on the topographic map. Or if you can check of this dam here, there's a dam wall here, and the dam goes like this. This gives us an area feature, that dam that you are seeing there. So the dam is also part of an area feature or a polygon, right? And then if we check some other features, like this road here is presented as a line. This is a line feature. This road is a line. It's a line feature that you are seeing there. Unfortunately, you cannot figure out a point feature, but we have some markings here. I think there must be a spot height, which will also contribute part of the point features on the topographic map. So the topographic map uses the raster format of storing data in GIS, like what we have witnessed there. Right, we move on to raster, like what we've been talking. We said raster, it uses grid cells or pixels. Right, the grid cells, you can see how they are looking like what you see those red markings there on that particular on those particular grid cells. That is the usage of grid cells to present the information using raster format. And also the pixels, we are using an example of an orthophoto map here. If you try to check there, you can see the roads are presented in images. You can see these roads here. They are just presented in images. The intersection here, the another road. We have another road going that direction. This one continues to the north east. This one goes this direction. All these roads, you can see they are presented in images. And also, if you check, we can actually see the trees that we are witnessing here, the form of vegetation in the area. We can see the nature of vegetation around the area. And also, if we try to check, you can also check and see the house roofs. They are visible, like this one here, this one also there. They are in the form of an image. So you can actually see those ones in the form of an image. So orthophoto, they portray or they present and store the features in the form of pixels and grid cells. That's the two ways of storing data in a GIS. Is vector data, which uses points, lines, and polygons, and raster data, which uses grid cells and pixels. Right, we move on to the different ways of presentation summarized there. Raster, view, and happy spatial entities, and vector view of the world. So we can see the differences there of raster presentation, and then the actual feature, and then the vector way of presentation of the different features. What you should mind here is on the raster column, we are using grid cells, and these are the actual objects. And here, using vector, we are using lines and polygons and area features. Right. Then we are going to processes in GIS. Right. Processes when working with GIS, we have data input. We are inputting data into the GIS system. And then we have data storage. After capturing, we put it into the system, and then we store it in the system. Then we can do data analysis, then output of information. After analysis of data, we can now output information which is more useful, which has been made to suit specific needs, and which is more understandable now, unlike raw data. Then we have data management. We're also going to look at how we manage our data. And then we have data application. Those are some of the processes that we have. Right. Then where do we get the information for GIS? For us to talk of the storage, the capturing, yes, and the storage, the manipulation, what. Where do we get such information? What are the sources of data for GIS? For us to say, we now have information to use or to store in the GIS system. How do we accumulate such information? Where do we get it from? Right, the first source is remote sensing. I think with remote sensing, you understand the meaning of remote sensing. This is actually the collection of information from a distance. We are capturing information from the Earth's surface without actually getting into physical contact with it. We use the different methods of remote sensing, like taking aerial photos or satellite images. That is remote sensing. Then we can also use survey data. Survey data, we actually do a survey, like on the roads, or census data. It's also part of survey data. People actually go and collect information. Right. Then measure data. We have data which is available from measuring instruments. Like, for example, rainfall. We have our weather stations where we have the rain gauges. They are responsible for collecting and measuring the amount of rainfall received in a particular area. It's measured data. Or we can talk of temperature from the same weather stations. We have the minimum and maximum temperature thermometers responsible for the measurement of temperature and also pressure. And also we can use secondary information, which is from other maps. Other maps can also provide such information. So basically that is how we can gather information that we will end up using in the GIS system. Right. Then the sources, again, we are clarifying the sources of information as primary or secondary data. The only difference there is primary is basic information, which is actually from the source as it is. We are having first-hand information from the source, that is primary. Then secondary, we are getting information already provided by other sources. The information is readily available from other sources. It has been collected on behalf of the person who is interested in finding the information. So it's already collected and it's mainly in written format that you can just go and collect the information from those sources that already provide the information. That is secondary. So our definition there, it says primary data refers to first-hand observations and measurements. First-hand meaning to say you are actually getting the information from the actual source. That can be done through surveying. You take a survey, physical visit to the area, or GPS points, you use your GPS receiver. Measurements, you're actually doing the measurements, or tests, or sketch maps, right? Then secondary data refers to existing data measured and captured by another organization, right? You have, for example, topographic maps. They have been captured, the information has been captured, and the maps are drawn. You can use those maps as secondary sources. Satellite images, attribute data in tables, models, and newspaper articles, those are some of the sources of secondary data. Right. How can a GIS be used to assist with the location of a business? We are now applying GIS in the corporate world. You want to establish a new business. How can you make use of GIS to ensure the prosperity and success of your business? Right. Find information about other existing businesses. Here we are talking of the competition threat. When you're locating your business, you can actually figure out the location of other businesses who have got potential to pose competition on your newly established business. So it's critical that you check on information of other existing businesses in the area from the relevant data layers and be able to figure out the best place to locate your business away from threats. Then also find the total population in order to analyze the potential market. Yes, your potential market is fed by the size of the population and also the level of income of the people. So you also have to look at the total population of the area. You cannot locate your business which requires support of many customers in an area that is sparsely populated. Maybe you need a minimum number of people to support your business. Maybe it's a minimum of 100 people. Then you go and locate in an area which is very sparsely populated, where you cannot even get half the number of people. It means you have failed to locate your business where there is a threshold population to support your business, and ultimately, a potential of failure of such businesses will be high. Then find financial statistics that show growth. You can also analyze and try to identify information on the financial positions and also the level of income of the potential customers in the area. Then also determine the income, like what I've said, of people in order to establish whether business will be feasible. Determine demand for the business. Yes, the demand comes in two dimensions, either determined by the level of income or determined by the size of the population, and also partly by the needs of the people in the area. You should be able to figure out the best that the people will want to buy from your business. Then work out routes for deliveries. Yes, you can also figure out the route network, the road network, or the rail network in the area if it's necessary, so that you can figure out your deliveries for the business in the area, and also find ideal location for the business, an area which is more suitable for location of a business. And then lastly, determine crime hotspots in the area. Remember, criminal activities are to the detriment of the success of the business. So you also need to identify areas which are prone to high crime risks and try to locate away from such areas. Right, so basically you can see we can apply GIS as a technique, and we can apply it to come out with informed decisions for different purposes like location of a business based on those arguments that we have been highlighting. Right, then we go to remote sensing. We've talked about remote sensing a little bit earlier on. Remote sensing is the observation of the Earth from a distance through satellites, aeroplanes, or drones. Right, that is the modern technology that we use to actually find information on the Earth's surface. We are not in physical contact with the Earth's surface, but we are able to find information through remote sensing, through capturing information from a distance, either using satellites, or can use aeroplanes, or can use the drones. They can also capture information from a distance. Then remote sensing is used to study landscapes, ecosystems, hydrology, atmosphere, climate change, human development, and the impact of humans on the environment. All those aspects are able to be captured by remote sensing. We can be able to capture the ecosystems and the balance of nature. We can be able to capture hydrology, the effect of human activities on river management and wetland management, and also can look at the atmosphere, climate change, human development. All those aspects can be captured using remote sensing technology. Then we have two types of remote sensing, which is passive remote sensing. When something is passive, we are saying it's not active. So sensors that measure reflected sunlight emitted from the sun, we rely on the amount of reflectivity that is sent back to the atmosphere from the energy that comes from the sun. That is passive. The sensors are not actually active. They are not actually collecting the information on their own, but they are relying on reflected energy from the sun. Reflected energy as the sun shortwave rays hit the Earth's surface and also some other different objects, they tend to reflect back the energy, and that the sensors now, they use that energy to actually get information. That is basically how passive remote sensing works. Like you can see here, the sun's rays, they are going to a particular object on the Earth's surface. This one is coming to this building. This one is also coming to the clouds, and the clouds will reflect back energy, and the buildings will reflect back energy, and also the trees will reflect back energy, such that there is emission here. This emission is the one that is going to be used by the remote sensors to actually collect the information. Right. Then active sensors, these are sensors that send light to their targets. These ones, they don't rely on the sun, but actually they send their own energy. And then the energy is reflected back, and they are able to collect information from the energy which is reflected back. It's their energy that they send, and then they measure the reflected energy which is sent back to them. That is why we are saying they are active. Active in the sense that they don't rely on the sun's energy, but rather they send their own energy and also measure the reflected effect back to them. Right. What are the advantages of using remote sensing in geography? Why is it beneficial that we adopt remote sensing as a way of collecting geographical data instead of us visiting the places physically? Right, data can be collected for inaccessible areas. There are some areas which are not easily accessible. Talk of the jungle areas where it's even risky, it's even life-threatening to visit such places. Some areas are of very rugged terrain. We cannot easily access those areas. So through remote sensing, we can just use the drone system to capture the information. We can just capture information using satellite images. That becomes easier to access information of those areas which are not easily accessible. Then also large areas can be captured as images, like we can talk of satellite images. The satellite images can capture information across the whole globe, which makes life easier. Capturing such information using the normal ways of capturing information, that will take us very long in geography. But using satellite images, you can now be able to access whichever part of the world through accessing the satellite imagery system. Then they can be delivered quickly. I think that is also another advantage. We can access them as quick as is possible. You can access any area of your choice. If you want satellite images of any place across the world, right away you can get it. It can be delivered to you as quick as is possible. You can access those areas as quick as is possible. Right, then we also have their consistent images over time. Yes, these images over time, like the satellite images, they are updated time and time. Whenever there's a change, you can actually see the change being updated on the satellite images. They can be updated time to time and give us the current prevailing geographical information. Right, active sensors can be used during the night or cloudy days. Right, we are talking of the active sensors. They can send their energy, and this energy can be reflected back, and they can be able to collect the information. Meaning to say, instead of us relying on the weather conditions, we can still use them when it's a cloudy day, unlike the passive system whereby we have to rely on the sun. So the active sensors can be used during the night. They can send their energy, and the energy is reflected back, and you can actually collect the information even at night, which makes it convenient in geography. Instead of us waiting for the day, we can still collect the information during the night. We can still collect the information on cloudy days, which makes it more convenient, right? Those are some of the advantages of a remote sensing. Then there is typical example of satellite images, which are taken using the remote sensing system. We have an image of flooding. You can see this is showing us a flooded area, and it's covering a very wide area which has been affected by floods. which is more convenient in geography. You can be able to figure out or ascertain the damages that have been caused. Damage to human settlement, damage to infrastructure, damage to human life, damage to the environment. We can figure it out using those images by what we are seeing there. Right. And also satellite image of deep sleuth. I think you can see a satellite image are showing a deep sleuth, which is predominantly an informal settlement. We can see there and we can be able to assess aspects like the need for housing, assess and estimate the size of population that can be inhabitants of that informal settlements. You can also ascertain the damage on the environment. We can also try to ascertain the social implications of the informal settlements. Right. That is the benefit of using such imagery. And lastly, we have an image of a tropical cyclone. Right. We can also be able to figure out the strength of the tropical cyclone in terms of the developmental stage of the tropical cyclone from that particular image that we have. And also we can be able to figure out the area or the hemisphere in which the tropical cyclone is affecting by analyzing the circulation trend of the weather system. Right. So basically, these are the images that we are talking about, which is part of the usage of remote sensing in geography to be able to capture information across the geographical spectrum using a modern technology without getting into contact with the actual ground. Then we have some other concepts. We have a database. A database is a collection of data organized for use in computers. It's a collection of data which is organized for use. So a database, we can access a database and be able to get specific information of geographical use that you might be interested in. Then we move on to data layering, or what we call thematic. Right, this refers to placing of one map on top of another to see the relationship between different sets of data. Right, there is a typical example or an illustration that we have here of data layering. We are saying data layering, we are projecting information one on top of the other. We are projecting different data layers, one on top of the other, for us to be able to ascertain the relationship between those different data layers. So we are saying information is portrayed in layers. This is information about street data. It's showing the arrangement of streets. Only, it is focusing only on how the streets are arranged. So we can see from this layer, we have a street which is going like that, and it's meeting with another street, and the two other streets, one goes to the north, it goes in that direction, one goes to the extreme east in that direction. This is a layer which is focusing only on the pattern of the street. And we are referring to the same area, the same geographical space. We are not referring to different geographical spaces here. If this is layer A, this is layer B, layer C, and layer D. All these layers, they are captured from the same geographical space, but they are only portraying different information, but of the same area. This layer is focusing on street data. This one is focusing on the data of buildings. How are the buildings arranged in that particular area? Where are the buildings? We have building number 1 there, another one is there, another one is there, and another one is there. This is only about buildings. It's giving us information from the same geographical space, but specifically it's specializing on the data for buildings. Then vegetation is showing us where vegetation is located and the nature of vegetation. We can see here, we can see those big trees. We can see an isolated tree here, some other form of vegetation. That is how it is located. Then we have integrated data. Integrated, we are saying it's now brought together. The different data sets are now brought together. Here we are seeing they are projected here, one on top of the other. That's the projection that we are talking about, placing one layer on top of the other. Then if we combine them, how do they relate? We now have this final picture as indicated by layer D, which is the integrated data layer. This is the same as this. And this building is appearing here. This form of vegetation and this form of vegetation is now here surrounding the building. If we look at this building here, it's the same building which is here. We relate it to the streets. If we check here, our street is going there and our street is going there. These streets are more likely to be this one here in front of the house. And this one here going this direction is the other one that we see there. And this building, you can see it is also here. And this vegetation is the same in front of this building. These trees are the same, these trees, which are to the north of this building. And if you are trying to trace this street here, we are seeing that the street is there. Here. So what we are saying is we are integrating these different data sets, we project them one on top of the other, and we integrate them to show how they relate to each other. That is basically data or thematic layering. It's projection of data, different data layers, one on top of the other, so as to figure out the relationship between or amongst the different layers. Right. What do we use data layering for? Different sets of data can be compared. Yes, we can compare different data sets by splitting them. We can be able to compare them. And the relationship between different sets of data can be established. Like we want to establish the relationship between settlement and vegetation. We can actually see it there from the layering effect. Or we want to relate farming activities to settlements. We can actually see the relationship by bringing the data layers together. We layer them or we project them, and we are able to integrate them and see the relationship. Then analyzing different sets of information. Yes, you can analyze different sets of information by splitting the data sets into different data layers, or comparisons can assist with future developments. We can make informed decisions about the future through analysis of the different data sets and the relationship between the different thematic layers. Right, then we go to data integration. When we're talking of integration, we are looking at bringing together. Right. The integration of data from different maps into one map, which summarizes the overlaying process, right? That is basically integration. We are taking different data sets and we are bringing them together. We are integrating them. We are making them part of one presentation, though they are coming from different maps. So we can see there we have different maps with different scales. One has got a scale of 1:50,000. The other one has got a scale of 1:80, 1:30, and another one 1:50,000. What are the problems of integrating data? We want to bring data from different maps, or we want to merge different maps of different scales. The first difficulty is that maps have got different scales. Merging a small scale map and a large scale map is not very easy because of the differences in scale. The features are not presented the same according to the differences in scale. A small scale map will be neglecting some information, while it's a large scale map will be giving details of everything. So merging those two might be a challenge. And also different map projections are used on maps, right? Map projections, they are also used differently, which means if a map is drawn according to a specific projection, it is very difficult to merge it with another map which used another different projection format. Right, when I talk of map projections, I think we are looking at how to standardize the maps. Like what we see when we are having our maps, they have got grids, those blocks that we have. But actually, if you are looking at the actual globe or the actual Earth surface, is not flat, such that we might not have straight lines of longitude and also having straight lines of latitude to give us regular blocks. It might imply that the blocks might not be regular, but however, because of projection, we tend to standardize them and make them regular so that we are able to study whatever we want to study. So there are different formats of projections which are used when maps are being drawn, which will imply that if a map has used another different projection, that might not actually tally with another different map using the other different form of projection. So it's a difficulty. Then different georeferenced maps are used, right? We also talk of geographical referencing of maps. If there are different georeferenced maps, that will also pose a challenge for one to actually integrate information from those different sets of maps. Then what is the importance to the geographer for integrating data? A summary of integrated data is produced, which makes it easier to analyze data. Unlike comparing different data sets from different maps, if they are integrated together, we can now be able to easily analyze the data. We are now easily able to interpret the relationships between the different geographical aspects. We are now able to show and see the relationship and make an analysis of the relationship based on the combined features, which are now presented on one map. Then this is a summary of how GIS can be used in different aspects of economic activities, like in agriculture, in crime prevention, in traffic congestion, in finance, in mining, and also in personal use. So GIS is equally important, it's very important because it can assist in dealing with all those aspects of human life. Right, we move on to another geographical GIS concept. We talk of buffering. Buffering is one of the key elements again. We define buffering as a process of demarcating an area around a feature. Demarcation of an area around a feature. For example, when we're talking of buffering, let's say our feature here is a river, right? Let's say we have a river. To illustrate buffering, if you're having a river and we want to buffer the river, maybe this is a major river, right? We don't want human activities to interfere with the river here, right? We don't want settlements to encroach close to the river. We do not want, again, farming activities to get close to the river, for they can influence the quality of water and cause different environmental harm on the river there. So when we're talking of buffering, we can put a boundary along the river. Maybe we can put a physical boundary, we can put a fence along the river. Maybe after some designated meters, we put a fence. This is to avoid interference of human activities on the river. We have to let the river flourish naturally without influence of human activities, because if humans can access the river, they can end up doing illegal dumping into the river, polluting the water, harming the ecosystem. Or we can also have people doing farming as close to the river, causing siltation of the river and the ultimate resultant problems like eutrophication of the river. Right. Or we can plant trees along the river so as to mark the boundary. We can plant trees along the river so as to mark the boundary between the influence of human activities and the river. It's like that people, whenever they come across this row of trees here, it signifies a boundary for human activities and the river, which will imply that human activities must not interfere into the river. That is some form of buffering that we are talking about. We are putting a demarcation or a boundary along a feature. Right. We move on to, that one is just an example, data manipulation. When we're talking of data manipulation, we're saying when data is processed and converted into useful information. For example, correcting distortions and sharpening definitions. We are manipulating data. Maybe we are having images which are not clear, which people are interested in, which they want to actually see and have some geographical understanding of what was happening. We can sharpen those images. That is manipulating. We are actually changing the information to make it more user-friendly, or to correct if there are some distortions. If there are some distortions there, we correct them. That is manipulation. Right. Then why is it necessary to manipulate data? To correct distortions, to sharpen definitions, to ensure color consistency, to correct latitude and longitude registrations, makes data more manageable. I think manipulation is very important whenever you collect data, before you are able to make informed decisions, you should first of all check on the information. If there are any forms of distortions, you must change them so that the information becomes accurate and consistent. That is manipulation. You are changing the information to make it more useful in some sort. You are correcting distortions whenever there is something which is not according to the desired quality. Right. Then statistical analysis is also another concept in GIS. It refers to the interpreting the various forms of statistics in relation to a query. A query, we are saying we have a question. So if we have a question, for us to get the answer, we have to do statistical analysis. We are interpreting the various forms of statistics in relation to a query. For example, here, recorded crime rates in selected South African urban police areas as of 2000. We want to figure out, our query is which province has got the highest crime incidences or crime rates. That is our query. So we have to go to the statistics and do a statistical analysis. Let's go to the statistics that are available and let's be able to compare the different areas and check the crime rates which were recorded in a particular time period so that we are able to get an answer to our query. So analysis, we are just using statistics available to make a comparison, and we are able now to come out with the answer to our question. Like, for example, we are looking at maybe different towns and cities in South Africa. We have a question: which city in South Africa is most prone to crime activities? We can check here. Durban has got 6.115. Port Elizabeth has got 8.361. West Metropolitan has got 9.699. Pretoria, 10.412. Look at Joburg. Joburg with 18.362, which means our answer to the question should be Joburg if we're worried about statistics in terms of criminal activities. Which one has got the highest? Which town, which city has got the highest criminal activities? We can actually conclude through statistical analysis. We are analyzing the statistics available and be able to come out with an answer to our query. Right, that is statistical analysis. Then lastly, we look at data standardization and related aspects. When we are talking of data standardization, we are saying it means to make the data similar to other data sets, so allow data sharing. When we are standardizing data, for example, when we are looking at our topographic maps, on our topographic maps, we know that the blue color is used for water bodies. Either it's a dam, it's a lake, it's an ocean, it's a sea, it's a river, it's a stream, it's a borehole, it's a water tank, it's a reservoir. All those water bodies, they are using a standardized blue color. If you take a South African topographical map, take a Zambian topographical map, take a British topographic map, take an American topographic map, they are all using the same standard to make data similar, such that when you take a map, you are not confused with the color code because you know blue has been used for water bodies right across. Whichever map you take, you are able to interpret it because we are making the data similar right across. That is standardization. And also that allows for data sharing. We can get to interpret a map which has been shared by a colleague from a different geographical space. We are able to share because the data is similar. That is data standardization. Right. And querying to investigate the data and find answers about specific parts of the data set. If you have a query, you have a question. Then, if you're querying, you are investigating the data to find answers. You have a specific question which is unanswered. And then you have to use the available information, the statistics that are available to get answers to your question. Then data sharing to make data available for others, for other users to access. When you are sharing, we are making it available to other people to be able to access it and also use and come out with their geographical conclusions from the same data set. Then data security, to ensure that data is safe from tampering and anybody do not have access to sensitive data. In most instances, we tend to find that our devices have got passwords, have got fingerprints, have got all those different forms of security. That is form of data security. We are trying to secure sensitive information so that it's not tampered with, and also people do not have access to sensitive information which is not to their consumption. So there are several security measures there, like you can talk of personal identification numbers, the PIN, you can talk of passwords, or you can talk of fingerprint readers, or you can talk of some other, instead of tampering, there are some read-only memory where one cannot edit information from a given device. Then we have backing up of data as the last thing. For data recovery, it's also an important part of data security. When you have a backup, you are saying your data sets are stored in different formats and in different devices, such that in case when one device has got a challenge, you can easily access from another device or from another storage format and be able to access the very same information, such that the information is not completely lost. Right, that brings us to the end of our discussion. That was our discussion on GIS. I think this discussion we've tried to cover up on some of the basics of GIS, but we haven't exhausted all. There are some other remaining aspects that are also of equal importance as the one that we have discussed here. But for the sake of preparing the learners for the GIS section, I think what we have covered is 3/4 of what you can expect in each and every paper, save for a few aspects which are not included in this discussion, but however, which will be covered in other discussions. Keep checking the platform. You will also get to access some of such missing GIS concepts. Right, that takes us to the end of our discussion. I thank you, your host, as usual, in geography, Conrad Mopinguri. Thank you.